Hi guys, welcome to Science in 5. We can explain it in 5 minutes. In this video, we're going to talk about indicators for acid and bases. Most acids and base solutions are colorless. That is why it is important to be careful when dealing with acid and base solutions. They look colorless, and our natural inclination is to feel that colorless liquids are like water. They're harmless. This is not the case with acids and base solutions. We can, however, use indicators to determine whether a solution is an acid or a base. An indicator is a weak acid HIN that has a distinct color before and after it loses its proton. HIN plus water gives us H3O plus IN minus. HIN has a color different to IN minus. So generally, as the pH of the solution increases, the color gradually changes from color 1 to color 2. As the pH of the solution decreases, the color change is gradual from color 2 to color 1. Since this is an equilibrium, the changes that occur to the equilibrium will determine the color of the indicator. To explain the color change that occurs, we will use Le Chatelier's principle. An example: an acid HIN is red and has a conjugate IN minus that is blue. What will the color be if a few drops of this indicator solution are added to a solution of HCl? To be able to answer this question, we must highlight 3 key points. First point, what is the stress that is applied to the above equilibrium? Second point, how will the system respond to the stress? And last point, what will be the effect of that response? HCl produces H3O plus ions, and the concentration of these ions increases. The system will respond by favoring the backward reaction to lower the concentration of H3O plus. The result: the indicator turns red. What if a different stress is applied to the system? We will still use the idea of Le Chatelier. What will the color be if a few drops of this indicator is added to a solution of NaOH? The NaOH produces OH-, which react with H3O+. The concentration of H3O+ decreases. The system will respond by favoring the forward reaction to increase the concentration of H3O+. The effect: the indicator turns blue. Now let's talk about how you can choose indicators for a specific titration. We're going to focus our attention on these 3: methyl orange, bromothiamine blue, and phenolphthalein. Methyl orange is orange in acid and yellow in base. Bromothiamine blue is yellow in acid, blue in base. Phenolphthalein is colorless in acid and bright pink in base. Methyl orange is useful to use for a strong acid, weak base titration because an acidic salt is formed during this titration and the pH range of the indicator is within the acid range. Bromothiamine blue is useful when you've got a strong acid, strong base, weak acid or weak base titration because of the neutral salt formed, and this would work well with the neutral pH range of the indicator. In the case of phenolphthalein, for a weak acid strong base solution, where we form a basic salt and the indicator has a range that works in that solution. So that is all for indicators now. Thanks for watching. See you next time.